and am I pronouncing that correctly? Chile, I apologize about that. Next, thank you.
Thank you, Dana. Thank you, everybody, to join this summit. So I'd like to introduce our project Nice Loo. We have a collaboration with Southeast Water and Melbourne University. And last almost 2 years, we have designed the Nice Loo technology. So what we have our technology for membrane bioreactor, and then we combine with our male and female toilet, and how we can try to mobilize our Nice Loo. So that's our target, and then we got support from the Southeast Water for funding, and we designed for this membrane bioreactor. So we have 200 liter of our urine to fertilize conversion technology, membrane bioreactor. We just say herbal technology. And then we have tested it for last almost half a years, and then optimize this process. And we can allocate this one in the trailer, in the middle of the space of the trailer, and then we can mobilize this membrane bioreactor system. And then we look at what's the difference from the lab scale performance and this pilot scale. And in fact, not pilot, it's a full scale of our membrane technology. And we made similar to like a refrigerator size. So this is very easy to mobilize and easy to carry. Also, we can have some small space occupation. So very compact and robust herbal technology. So this is performance. So we have collected our urine from this building. So I'm sure that you already donate kindly for your urine, and we collect from the basement. Now we are operating in the upstairs. So if you want to see this herbal technology, it's on the operation, the level 12. So during lunchtime, after lunch, and you can just visit there, and we can show you around if you're interested to see. So we can organize just very short visit of our laboratory and technology, also basement urine diversion system. So this is our result for last almost we have operated 160 days. Yeah. So initially in ammonia and then nitrate concentration. So we like to have a balanced ammonia and nitrate fertilizer because they are one of the most widely used nitrogen sources. So we put the initial concentration a little bit lower to stabilize our bacteria, AOV bacteria and NOV bacteria. And then finally from day 75, so you can see the second result of the space, HLT7, HLT5, HLT3, and HLT1. So depending on the HLT, so what kind of the fertilizer component, ammonia, nitrate, nitrite, so what kind of the component we produce, and then this kind of nitrogen source, how this will impact overall our plant growth. So that's we compare. So HLT7, which means there is no nitrite, so mostly ammonia nitrate. And then when you have HLT5, so you can see the gray color is the nitrite concentration. So you can see the little bit of higher concentration of the nitrite. So you can see on the top of our ammonia nitrate concentration. So there is some concentration is there, and then HLT3 and then HLT1 day. So they increase because they don't have enough time to convert the nitrite to nitrate. So when you have a smaller the HLT, so we have a more high concentration of the nitrite. So we test it as it is because nitrite also itself can be a good fertilizer as a nitrogen source, even though ammonia nitrate are the most widely used fertilizer, but we look at what's the impact of the nitrite concentration in this system. So you can see the concentration overall ammonia HLT 753 one day. Then you can see the ammonia concentration initially around 3.5 gram per liter, HLT 2 gram per liter, 2.2 gram per liter, HLT 3 days, 2 gram per liter, and then HLT 1 day, 1 gram per liter. So you can see those nitrate concentration was very much similar 0.4, 0.1, 800, 500 milligram per liter. And nitrite, so when you have a very high HLT, so most of the nitrate are gone. And then when you see the HLT1, so they have a very high concentration of nitrite. So what's the nitrite concentration will impact overall our fertilizer performance. So this is we also design. So we have done the plant demonstration. Then we found out mostly nitrite performance is very much similar to our ammonia nitrate concentration. So which means we diluted our fertilizer because initial the urine fertilizer concentration is almost 10 gram per liter. So you need to dilute your fertilizer 10 times, at least 10 times. Otherwise, you will have osmotic pressure and the plant will be dry because water is coming out through your osmotic pressure. So you dilute your concentration, HRT1, the nitrite concentration was 1 gram per liter. So you dilute to 10 times, which means 100 milligram per liter of nitrite concentration. So it can be used as a good fertilizer as it is. So that we found out based on our operation, so we can use even though HRT1 because nitrite doesn't really impact much. But it's true, like when you have HRT longer, 7 days, ammonia nitrite fertilizer has a little bit better performance of your plant growth. So that's the overall our finding from our project. And then we have two options to operate this condition. Rather than if you have too much urine coming through your reactor, so we can have first like a high flow rate, and then you have HLT 1 day, a little bit faster. Then even though you have a high nitrite concentration, it can be used as a fertilizer. But if you don't have enough urine, so we just operated our NBR system for pH adjustment based on you have AOV bacteria, and then this will decrease the pH. So we add our high pH the urine, hydrolyzed urine, and then you can adjust the pH around 6 to 6.5, which is the most favorable pH for AOV, NOV bacteria for nitrification. So we have two options to operate. One is depending on the pH, we can control when we don't have enough urine. But when you have a lot of urine, so we can just decrease the overall HLT. And then even though there are a lot of nitrite concentration, but it can be also used as a fertilizer. So based on this one, so we have designed the trailer, and Ibrahim was Southeast Water people. We collaborate together to look at how we can make a good male toilet in the middle. So you can see this is the male toilet, and the other side is female toilet. You can see the pedestal toilet 3, and then we have a male toilet 2, and then one is the pedestal toilet. So we have designed this one, and then in the middle space, so we located all the storage tank and NBR system. We will mount it in the middle of the trailer. Then we have a urine diversion toilet we purchased from the Urimed, as well as Rao fan. So this is the male urinal. So you can see, you can buy just $1,000. Then you have also LCD monitor there. So you can have some educational program. Also, Professor Joe showed a lot of nice videos. So we will just put together. Then you can, while you are doing pee, and then you can see some of the education nutrient recovery system. Also, we have purchased Lao fan. So this is pedestal toilet. You can convert the urine and feces. So we also installed our urine diversion toilet system, and then how we can collect the urine. And then we just pump to the storage tank in the middle, and then we process our urine to fertilize and apply directly on the parkland and the space. That's what we have designed. So you can see the design from the last 1 years, and then this is we already completed, and it's coming to Sydney very soon, and then we will also make sure that all the plumbing code and the connected all the urine diversion pipeline, and then our MBL urban technology, and we can stabilize this system and try to move around Sydney, Parkland, also Melbourne, possibly Brisbane. So we will see how we can collect better and operate this Nice Loo system. So this is timeline, and thank you for your attention.